And we'll touch briefly here on compaction. Compaction is becoming a bigger concern more and more here. For years we thought up here we were immune to compaction because of the freeze and thaw cycle. We freeze really, really hard and really, really deep. And for a long time, yes, that did make quite the effect. But the thing you got to keep in mind is if you have true compaction, what is compaction? That is when you've forced all the air pockets out of an area of soil. How does freeze and thaw work? Well, when it freezes, it's not that it freezes the soil, it's that it freezes the water in the soil to cause the water to expand as it turns into ice, and that's what breaks up your soil, right? Well, if you pack down all the air pockets, where does water normally stay in soil? It stays in the air pockets in the soil. If you don't have air pockets, that means you don't have moisture in there. If you don't have moisture when it freezes, what expands? Nothing. So if you have true compaction, freezing and thawing doesn't have the effect that you think it does. Penn State did a really good study here a few years ago. If you go online, you can find it, or I can email you copies of it. And they did a worldwide study. So it wasn't just Pennsylvania. They went all over the world, tried to find places that had on average 40 inches of freezing. Okay? And what they found is if you had a true compaction layer down to the 10-inch range, it took 5 years for freezing and thawing to remove that layer, assuming you never drove on it again. That was just creating a compaction layer and walking away. It took 5 years. From 10 to 20 inches deep, it took 10 years for freezing and thawing to remove that layer. Anything below 20 inches had to be removed mechanically. Okay? So freezing and thawing isn't having the effect that a lot of us think it does. What's really changing things now for us too is we're going to these bigger combines. We're going to bigger tractors. Going to grain carts. Grain carts are one of the worst compaction tools out there. Combines with really big heads. We're getting a lot bigger, and even though we're putting more rubber on there, that's not having as much effect as you think either. The next thing that these guys at Penn State did, and it was an amazing field presentation they did, they brought in 2 identical manure wagons fully loaded. But one of them had fairly small tires on it, the other one had really big tires on it. And what do we do here? We get a bigger tractor, we dual it up, we triple it up, we go to tracks, right? What they showed though, they actually put little scale sensors in the soil. One was about 5 inches deep, the other is about 12 inches deep. When they ran the carts over, the shallow sensor did show a lot lighter weight for the bigger tires. Okay? Can't remember what the exact numbers were, but it was significantly less weight at the 5-inch range. At the 12-inch range, they weighed the same. As you get down deeper, all your compaction is directly related to axle load. And once you have more than a 6,000 pound axle load, you tend to have compaction at deeper depths. So that was a real eye-opener for me to see that. And if you talk about track systems as well, although track systems do spread it out, again, you're still dealing with basically 2 axles on there. The bogey wheels take some of the weight, but the majority is still on your rear drive pulley on there. So they have that broken out on that study of how much each one actually compacts. So if you're worried about surface compaction, going to bigger rubber, going to tracks will make a difference. But if you're worried about down deep, either start throwing more axles on or start finding a way to either control it through controlled traffic or alleviate it through deeper tillage tools. And that's where we're going to show it here. We're going to have our Smart Till, which will reach down to 8 inches deep, and our Subtiller 4, which will reach as deep as 18 inches. Now, we're going to go around here a little bit. We've got one of these soil penetrometers. Kel and I were playing with it here a little bit just before I came up, and we were finding, the old rule of thumb is once you hit 200 psi of compaction, you'll start to notice root deflection. Roots will start to grow around it to try to find an easier spot to go. But once you hit 300 psi, roots just won't push through it anymore. Just here on this hilltop, we were finding compaction range anywhere from 6 inches to 9 inches deep. So we do have an issue up here in the high spot. I don't know how much of that was caused by us trying to work this yesterday, but so to alleviate something like that, we would use a tool like the Smart Till or the Subtiller 4. Now, another important thing to keep in mind, a lot of guys, when they tried subtillers years ago, they or subsoilers, they say, well, it goes 20 inches deep. Let's put her 20 inches deep and let her buck. I got the tractor for it. That's a mistake. What you should do is go out, find out where your compaction zone is, and set your machine to go 1 to 2 inches below that. If you have different levels throughout the field, set the machine to go below the deepest level. Any deeper, if you work any deeper than you need to, all you're doing is just wasting fuel. You're not getting any benefit. And what can actually happen is, if you loosen it up, sometimes that soil being loose, you can actually pack it down to the level that you work to. So if all of a sudden you start working that thing 20 inches deep, and that's the deepest you can go, you ain't going to be able to reach down deep enough to tear it out next time.